Okay. This presentation explores the implementation of load frequency control in the Baltic states electric power system block as they prepare for synchronization with the Continental Europe. The shift marked a significant regional transformation requiring regulatory, technical, and operational adjustments by transmission system operators. The presentation outlines the LFC hierarchy, balancing market integration, and reserve management strategies, including the role of providers with limited energy providers. We conclude by emphasizing the importance of coordination, compliance, and innovation in achieving a secure and stable electricity system aligned with European standards. The electric power system block are transitioning from the one synchronous system to full synchronization with Continental Europe. This requires TSOs to implement advanced LFC mechanism and compliance with the Synchronous Area Framework Agreement. The objective is to ensure a secure, stable, and harmonized electricity network. The synchronization process include align with the frequency containment, restoration, and balancing standards applicable across the Europe. This background sets the stage for understanding the technical market and regulation aspects, explodes the following slides, emphasizing the importance of regulation and cooperation and adherence with European Union-wide operational norms. The paper sets out four main objectives. First, to define the purpose and structure of LFC and required by Continental Europe. Second, to clarify the roles and responsibilities of TSOs within the LFC hierarchy. Third, to describe the control mechanism and technical requirements necessary for frequency regulation. And fourth, to provide an overview of the balancing market and its operational logic. These goals align with European regulatory expectation and support the integration of the electric power system block into the broader power system. Each objective contributes to developing a stable, transparency, and efficiency frequency control environments. LFC operators within a structured hierarchy that ensures coordinated frequency regulation. The hierarchy includes first, monitoring areas, second, LFC areas, third, LFC blocks, and fourth, synchronous area. Each level has specific roles such as measuring power flow, contributing to restoration, fulfilling performance target, and maintaining overall frequency stability. This layered approach helps ensure system resilience and allows for clear allocation of control responsibilities. Understanding this structure is crucial for comprehending how TSOs collaborate across borders to maintain a synchronized and reliable power grid within the Continental Europe framework. Core LFC processes include the frequency containment process, second, frequency restoration process, and third, replacement reserve process. These processes are activated sequentially in response of frequency deviation, deviation. Yes, of course. The frequency containment process stabilizes the system immediately. Frequency restoration process restores the nominal frequency set point, and replacement reserve process replaces activated reserves to maintain long-term balance. Each process is managed at different operational levels with specific roles for TSOs and balancing service providers. Understanding the activation sequence and responsibilities associated with each stage is essential for ensuring system reliability and compliance with Continental Europe requirements. Balancing market ensures that TSOs can maintain system frequency and secure service availability through structured processes. These include reserve dimensioning based on system needs, capacity procurements to guarantee readiness, and energy procurements for real-time adjustments. The European balancing framework promotes competition, transparency, and of course, no discrimination. It allows diverse providers, including distributed energy resources and demand aggregators, to participate. This mechanism improves efficiency, lower system cost, and support innovation. The electric power system block must align their market processes with these harmonized roles to ensure successful integration and continuous system balance across the Continental Europe region. Frequency restoration control error target values are key performance indicators within each LFC block. They measure the effectiveness for frequency regulation and requires compliance with two performance levels. Level 1, less 30% exceedance, and level 2, less 95% exceedance. Targets are calculated based on statistical analysis for area control error and frequency deviations. These thresholds are established to maintain system stability and are regularly validated using operational data. Adherence for frequency restoration control error target ensures reliable operation, regulatory compliance, and enables TSOs to evaluate and improve their control strategies over time. Three main reserve types support frequency stability. First, frequency containment reserve. Second, frequency restoration reserve. And third, replacement reserve. Frequency containment reserve acts immediately to counter deviations. Frequency restoration reserve restores system balance over minutes, and replacement reserve sustains the balance long term. Each reserve have unique activation methods and technical requirements. TSOs must plan, procure, and coordinate reserve activation based on system need. Understanding the role of each reserve type is critical for balancing market, operational, and maintaining system reliability, especially during unexpected disturbances or major fluctuations in generation or consumption. To participate in frequency restoration reserve or AFRR provision, balancing service providers must undergo a standardized prequalification process. This includes technical testing to verify response time, ramp rates, activation accuracy, and communication capabilities. Providers with limited energy reservoirs, such as batteries, must also submit detailed energy management strategies. These strategies must demonstrate sustainable reserve delivery without depletion. The prequalification process ensures that all providers can deliver services reliably and continuously, supporting system stability and market efficiency. This process enhances trust in market participants and aligns with European harmonization efforts. And conclusions: a robust LFC structure comprising monitoring areas, LFC areas, LFC blocks, and a synchronous area. A synchronous area is essential for maintaining frequency stability. Integration depends on accurate reserve dimensioning, reliable FCR, FRR, and RR activation, and regards prequalification for balancing service providers. Readiness approval must be renewed if technical conditions change or equipment is upgraded. If a facility exists an FCA group, its capacity must be deducted and recalculations performed if its output cannot be estimated. Limited energy reservoirs participation adds flexibility but requires clear management strategies. And the synchronization with Continental Europe demands cooperation, operational compliance, and transparent market operations. Thank you for your attention, and now time is for questions.